your journey of proofs in Trig. Proofs in Trig. Now, here's the scariest piece of it. There's no one way to do it. So the way I do it might be different from the way you do it, but we're going to get to the same solution as long as you're following the same, like if you're using the right identities, we're going to get to the same solution. Okay. So the most intimidating part is, where do I start, right? So this like the whole thing on the front page are hints, little tips on what to do to like get you a start on proofs. First thing first, make sure you know those identities, okay? And also know their equivalent forms, like that cosine squared is 1 minus sine squared, that kind of stuff that's on the bottom, right? Everything else that can be flipped around, they'll be equivalent as long as they're identical, right? The key to a proof is to work on the side with the most work. So when you're picking a side to work on the one that looks the most complicated. Yeah? Because the more work to do, the better. The easier it will be to simplify. If there's not a lot to do, it's going to be really hard to simplify. All right? Here we go. You'll see. You'll see. Sometimes, the majority of the time, if you change everything to sines and cosines, you're good. You're good. Okay. So changing everything to sine and cosines gets you pretty far with proofs. Factoring, right? Only factoring, if you can, should be performed. Yeah? Okay. And the side that you don't pick. Because I'm going to show you how to do it both sides, but for the most part, you're just going to be solving one side of the proof. One side of the proof is going to be your working side. The other side is going to be your goal. And your goal is basically the answer. It tells you what you're supposed to get. So none of these should be like question mark. You're already going to know what the answer is. So one side of the proof is your goal. The other side is where you work. In college, they usually don't let you work both-sided proofs, only a one-sided proof. So if you practice the one side, you'll be good to go. You'll be good to go. Yeah. And last but not least, the conjugate. The conjugate. Okay. Anybody remember that word from algebra 2? Yeah. No. What is the conjugate of A plus B? A minus B, yeah. A minus B are conjugates because if you were to FOIL this, this will get you A squared minus B squared. So if you multiply by a conjugate, then you can use the difference of squares. Okay, and I'll show you in a little bit. That'll just come up a few times around. I believe the first one should look like really, really, really familiar. That's it? I think we did it a couple times. We're good. Okay, we're starting off easy. Here we go. Here's what I like to do. Split it down the equal side. Split it. I hit the board. One side is the working side. The other side is the goal. The working side is the most complicated side. So the left or the right? The left. The left. This is where we work. And this is our goal. Right? So you do all your work on the side that is the most complicated. Yay? Here we go. One of the tips was change everything to sines and cosines. If you can change the sines and cosines, you're good. Cotangent is? Cos over sine. Sine is just sine over 1. And secant is 1 over cos. What happens? Cancel, 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 cancel. Answer is 1. Checkmate. That's a proof! You just did your first proof! I know! It's so exciting! No! 1 divided by 1, sir. Oh. Wait. I did! What happens when you cancel in division? What's a number divided by itself? It's 1. So when you start canceling, thank you for bringing that up. If you cancel, all of these just become a bunch of ones. So 1 times 1 times 1, 1. Right? When you cancel with division, it's 1, not 0. Good old inverse property. Okay? Okay. Are you ready for your second proof? I feel like we can step it up a little bit. Turn to the next page. Here you go. It's a good one. Yeah. Yeah. Okay. Split it. Which side is the goal, left or right?
Right.
The right is the easier side, so this is your answer right here. That's your goal. Okay. All right. There's so many ways we can start. Take a look at your identities and talk to me. What do you want to do? Okay. Do you see something else? You can factor it? Thank you for saying that. Hang on. Miss Zara said we can factor it, except that it's not a difference. It's a sum. So this cannot be factored. Yay? Yay? Okay. Let's stick with the change everything to sines and cosines since that works so well for us. Okay? It works so well. Does anyone see another way to do it before I go? What do you see? This one is? Yeah. What's tangent squared plus 1? Secant squared. I love it. I love it. Here we go. This is just secant squared. You're right, Paige. Okay? And now let's do a hybrid. Let's do a hybrid of Paige's method and then Anthony's method. Anthony said to change everything to sine cosine. Cotangent is cos squared over sine squared. And secant is 1 over cos squared. What happens? Cancel. So we're ended up at 1 over sine squared. How am I going to get the other side? It's equal. 1 over sine is cosecant. Equals check. Made. Love. Yes. You keep on getting it till the other side is equal. That's it. I already told you the answer. Yeah. Uh-huh. Woo. The plus 1. So all of that, the tan squared plus 1, if you look at your fundamental identities, that is equal to secant squared. That whole thing is secant squared. Look at the middle. See it? So you can replace it. It ain't. Yes. Yes. You'll know it so well because I've made you do it 17,000 times, but yes. Okay. All right. Are you ready? I know, this is so exciting. It's so exciting. All right. This one's hard to tell. Which one has the most work? I don't know.
The left. Left got the most.
This is kind of equal, right? It's kind of equal. All right. So let's pick a goal, left or right.
The goal is right.
You want to do the left goal? I like it. Okay. Yep. If you pick the right as your goal, that's fine as well. All right. Here we go. On the right side, it says we have to do some algebra. Are you ready? This is like a plus b, a minus b. Right? So this would be 1 squared minus cosine s squared. Okay? Which is 1 minus cosine squared s. I got you. S is just theta. It's the same as theta. I just use a different letter. Right? This is, if you remember what Miss Craig said, right? Miss Craig, this is called dose, right? Difference of squares. 1 minus cosine squared is sine squared. Okay. How are we going to get a sine squared out of the tangent squared? Thank you. tangent squared is sine squared s over cosine squared, right? And secant is 1 over cosine squared, right? Yeah. So since these two cancel out, that does give you sine squared. Therefore, this thing is tan squared over secant squared. S equal check. Check. Because you look at the answer. You look at the answer, and that's like what you need. That's your goal. That's what you need to get to. Like your goal to become an engineer. Sorry. The co-squares cancel out. That's why it's sine squared. How'd you get tan squared? What is, okay, so, Say again? Okay. All right, so we know that this is sine squared, right? And our goal is tan squared over secant. Well, if we change tan to sine over cos and secant to 1 over cos, this reduces down to this. It's the same thing as this. I already tell you the answer. I already do. Paige. Good for you, mates. Okay, we're going to do the both side ones. Yes. So here's the deal, right? Depending on who you have for math, right? They want you to just do either one side or you can work both sides. If you make, as long as you make both sides equal, we're good. We're good. And I'll do that for the last problem. Yeah. For the one-sided ones, practice one side. Practice one side. Okay. All right. Here we go. Again, equally as confusing as to which the side the goal is. Okay. The way you pick it is you want to pick the one where you have a plus or minus in the denominator. So this is going to be our goal. And the one with the denominator that's complicated is the working side. Okay? Here we go. Since we have a minus in the denominator, you have to multiply this by its conjugate. So what's the conjugate of secant minus tan? Secant plus tan. Exactly. So we're going to multiply this by secant plus tan. And I'm just being lazy and not putting the x. Is that okay? Yeah. Okay. Yeah, that's not okay. Yeah. Whatever you do to the bottom, do to the top. So secant plus tan at the top. Okay? Now, since it's the conjugate, the bottom is just going to be secant squared. Do you believe? A squared minus b squared when you multiply by the conjugate. Yeah? Okay. At the top, sure, whatever. Here we go. At the top, we're going to have cosecant times secant plus tan. Question, what's secant squared minus tan squared? What's secant squared minus tan squared? It's on your paper. It's what? It's 1. Where is that? Right there. Because tan squared plus 1 is equal to secant, so therefore secant minus tan is 1. Right. So this bottom one is just equal to 1. That's it. Okay? Now, the cosecant, secant, and tangent, we're trying to get to this point, right? So the cosecant, secant, and tangent, I would definitely change everything to sines and cosines so you can see what happens. Okay? Okay? So that bottom part is just 1. Secant is 1 over sine. True? Yay? And then cosecant is 1 over sine. Secant is 1 over cos plus sine over cos. Is it so much? Is it so much? Oh, so the bottom is 1. So all you gotta do is change the top. It's wonky sauce? Is that what you said? It's lost in the sauce. You do? Oh gosh. Yeah, yes, Paige.
I hope you know, I still don't know how to solve problems. So this is just hard.
Yes, because you're still unfamiliar with the identities. So let's go back. Let's go back to the beginning, right? In the beginning, for this type of problem, if you see a minus at the bottom, then you do the conjugate. That's usually what you do. Okay? Step 2, simplify if you can. Step 3, we're just going to change everything to sines and cosines because that's what we do when we can't do nothing else. Yes, no, maybe. Okay. Okay. We ready? Eh. Eh. Alright. Let me make sure I'm on track. Hang on. Yeah. Eh. Oh, dude, I was already there. Man, I was already there. Look at the solution. I was here, and I have everything but the 1 over sine squared. I was already there. Sorry, right? This is secant, and this is tan, isn't it? I did not need to do that. Because look at the answer, right? I'm glad I took a look because, well, that was the perfect example of look at the goal, right? Okay, let's step back. So if you take a look, are you good up to where we got the equals 1 part page? Yeah? So just look at the top, right? And then compare that to the goal. We have the secant plus tan part done. And all you need to do is put it over sine. Well, secant is 1 over sine. So all we need to do was put secant as x plus tan x over sine. That equals, and check. Yay? Yay. It's the same thing. Alright. Okay, here we go. So, with Paige, and if everybody else want to do it, you can work both sides. Here's the rule, though. You can't hop from one side to the other. So you know how in algebra you can subtract the same thing from both sides? Don't do it. If you're going to work to one side, get to a point, and then start over, work to the other side, get to a point. So here's how you do both sides. Okay. All right. In order to work both sides, first of all, here we go. You're working between the left side and the right side, and just make sure that what you're working on can be reversible. Okay. Oh boy, they are there. Yeah? Okay. So here's what I'm talking about. We good? Okay. Here's what I'm talking about. It's gonna be okay, love. It's gonna be okay. All right. Split that down in half. All right. Here we go. For the right side, the x squared, the cosine squared should be in the front. So I'm going to go ahead and change the order of this. So it's going to be cosine squared minus 2 cosine plus 1 all over negative sine squared. And there's a bunch of thetas all over the place. Oh my gosh. All right. Okay. Can we factor 1 and get to negative 2? No. So there's really nothing else we can do for that first one. Is there anything we can do? No? Okay. So here we go. Or actually, we can, oh, hang on, no. We can separate negative 1 is negative 2. Oh, but we're doing it by a monomial. So, you can't do dose nomials? What? That's so weird. All right. How about this? I just want to make sure we're not going to get too far off track. Right? If you do, no, that's not happening. Okay, we're going to leave it there. We'll leave it there. Okay. So, Eddie, you're taking up time. Here we go. On the left side, notice that we have a plus at the bottom. So multiply that by its conjugate, which is, it's okay. Yeah. This is cotangent minus cosecant of theta. Yeah? Okay. And whatever you do to the bottom, make sure you do to the top. So cotangent minus cosecant theta. Okay? At the bottom, it's going to be cotangent squared minus cosecant squared. Cosecant squared, because it's a difference of squares. Yeah? And at the top, if you were to distribute, right, you would get cotangent squared minus 2 cotangent times cosecant plus cosecant squared. Like that. Because when you do the outer and the inner, there's 2 where you multiply the 2 cosecant and cotangents. Do you see it? Because the bottom is difference of squares, so it's just a squared minus b squared. What's that? Where is it at? Oh, minus, yeah. That says minus cosecant. You're right. Okay. The top says cotangent minus 2 cosecant plus cosecant squared because negative times the negative is a positive. Oh my gosh, Daddy! You found it! You found it, right? Isn't this just equal to 1? Okay. All right, so here we go. We're almost there. So on this side, we've got cotangent squared minus 2 cotangent cosecant plus cosecant squared. Okay? All right. Now, let's go back to the other side. You did? You gave me the entire page. You're crazy. Okay. On this side, if you divide everything by sine squared, so you're going to get cosine squared over negative sine squared. And then this is going to be a minus 2 cosine squared over negative sine squared plus 1 over negative sine squared. Where? Oh, no, there's no square for the middle cosine. What's the first one? This is tan? It's what? It's cotangent. Yeah. This is negative cotangent squared, right? Okay. Plus. It's all good. Yeah? Here we go. So this would be a plus, and then you've got a 2. You good? Yeah. Cosine over sine is cotangent, but you have an extra 1 over sine, which is the cosecant. Because cosine over sine squared, let me break it up. This is this is cos over sine times 1 over sine, right? If you were to break up that middle. Oh. Sine squared. You have 2 sines at the bottom. Yeah? Yeah? And then last but not least, 1 over sine squared is cosecant squared. We're almost there. It's almost there. All the signs are just flipped. So if you just flip all the signs, reverse it, because the GCF is -1, this is the same thing as cotangent squared minus 2 cotangent cosecant plus cosecant squared equal to each other. Check. Yeah, the GCF of -1. Oh, this should be -1. Sorry about that. Is that right? Yeah, no, this is -1. Sorry about that. Divided by -1. Yeah. This is divided by -1. Sorry. Yeah. No, sorry about that. So the bottom, if you look at your thing, right? It says cotangent plus 1. Sorry, cotangent plus 1 is cosecant. Well, if you switch the places of the cosecant and the 1, it's going to be a negative. Yeah. The GCF is 1 from both sides. -1. -1. Sorry about that. Yay, nay, maybe. Okay. All right. Practice makes perfect. Perfect practice makes perfect, actually, right? So tonight you're going to practice just the first half of it. These should be the easy ones. Tomorrow you're going to have the difficult ones. Hang on. Tomorrow for the sub. Do not turn anything into the sub. You're going to add tomorrow's homework to all of this, so it's just all one big thing. Okay? What's up? Start now, because I'm telling you, you want my help while I'm in here. Okay? If you are having a hard time tomorrow, go ahead and text me. I'll be looking at my phone. If you need any help, just let me know, and then I'll get back to you as soon as I can. That's good? Not in class, silly. There we go. While you're working. All right. You got 30 minutes. Get started.